Okay, so the next problem is number 9 in your book, and we have y prime plus 2xy squared equals 0, and our function is this rational function, 1 plus x squared. So the question again is, well, they want you to actually to prove, right, verify that this function is a solution to this differential equation. And notice this equation, right, has x and y. So we have two variables, or it's a multivariable equation. And so let's start substituting. So we have this guy. Now, anytime you have a rational function, right, we actually want to write, so let's just recall a few algebra properties. Remember that 1 over x to the n is the same thing as x raised to the n. So I'm going to go ahead and use this to rewrite this rational function. So we have y prime, so this guy, first of all, is 1 plus x squared, right, quantity to the negative 1, right, because this is a quantity. So we have 1 plus x squared, right, to the negative 1. All of that is, and maybe just to emphasize this, I'm taking the derivative of all of that, right? I'm taking the derivative plus 2x, and then I'm going to take my y and I'm going to square it. So again, this is my y, this whole thing. 1 plus x squared raised to the negative 1, but I need to square it. So all of this is squared, and that should be equal to 0. So I'm taking the derivative here. Okay, so this is a prime, this is a tick mark, and that's a negative 1. Be very careful when you're writing this out. So I'm going to take the derivative of a function raised to a power. So we're going to use the power rule. But we're also going to use the chain rule because this is not just a factor of x. So maybe let's recall a couple of other things. So remember, the derivative of x to the n is nx, and then we subtract 1 from the power. And the chain rule we've been using a lot, which is the composition of functions. So we have this function. So if you take the derivative, right, my n is negative 1. So I'm going to bring that down. So that's going to be negative 1 times whatever's inside, right? I mean, the general one is x, but here we have 1 plus x squared. And we subtract 1, right? So minus 1 is negative 2. And then let me maybe get another color here. So, and we'll use yellow. I'm from LA, so a Laker fan. Well, my husband's a Laker fan. I'm a Clipper fan, but so this is the function, right? 1 plus x squared, and the derivative of that guy is well. So I'll just again write it out because it's good to see the chain rule in use. Okay, so plus 2x, and then here we're not taking the derivative because this is negative 1 and I'm squaring that. So one of the power rules in algebra, or exponential rules, is we can multiply these guys, these powers. So this is 1 plus x squared, and right, this guy is negative 1 times 2. And oh, let's see, let me maybe write in different color here. So I'm using xm to the n, right, is xm to the n, m times n, right, where this is my m and that's my n. So that's the property of, or law of exponents that I used. Okay, so if we continue, let me get my white. Okay, so simplification. So we already took the derivative. the derivative of this guy? Well, the derivative of a constant is 0, and the derivative of x squared, right, using the power rule is 2x to the first power, which is just 2x. And we can write that in parentheses, and this has no derivatives. That's squared, and that is negative 2. Okay, so we can put these two factors together. So negative 1 times 2x is negative 2x, all to the negative 2, and then I'm just rewriting this guy. Okay, so we're almost done. So in algebra, when we have exponential negative exponents, we want to rewrite them as positive exponents. So we're just going backwards here, right? Negative 2x times, right, another factor is 1 plus x squared, right? I'm using the 1 over x to the n rule, which is x to the negative n, plus 2x over 1 plus x squared squared. So notice the denominators are the same, so I'm allowed to add these terms. Well, negative 2x plus 2x is 0 over this same denominator, but 0 divided by anything is 0, and so again, 0 equals 0. Thus, let's see, our y was, what was our y? It was, so y equals 1 over 1 plus x squared is a solution to y prime plus 2xy squared equals 0. So again, this is a first order differential equation. So hopefully that makes sense.